Folks, we're doing our last part of the chapter in our textbook, which is chapter number 2, which gives us more information on deduction and induction. This is the part of the chapter where the author, as I like to call, ties up a smattering of conceptual loose ends. Now, the first one that the author discusses is a concept called indirect proofs. There is a chance that you may not see this again on an examination, but this is something that if you were to see more formal logic, you would encounter something called indirect proof. The most well-known version of an indirect proof is called reductio ad absurdum, AKA, in plain English, reduction to absurdity. If you've taken something like an intro to philosophy class, you have probably heard this concept before. Now, the reason why we call it an indirect proof is because we do not actively make an effort to prove what we're actually trying to prove. Instead, what we do is we begin by taking the opposition. In other words, we say, assume that our opponent's position is true. Now, after you start out by assuming the opponent's position is true, you construct a number of statements that are consistent with your opponent's position. And from there, you use the methods of deductive inference that we were talking about a few classes ago from propositional logic. Modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism, and more, as well as what are sometimes called the rules of replacement or rules of equivalence. In other words, there's a lot more propositional logic rules than we have gone over in this course, partly because this is just a short overview. Now, the idea is, if you take your opponent's position, we can simply call it P. We set up a bunch of premises that are consistent with the opponent's position, and take a guess what the last line of our proof should look like if we've done reductio ad absurdum properly. The last line of our reductio ad absurdum would be P and not P. Or I'll put it in more proper propositional logic form. P and not P, because this dot means the same thing as our real life word and. P and not P is what logicians and everybody else, hopefully, refers to as a contradiction. The reason that we call this a contradiction is because this statement is necessarily false, no matter what the truth value you plug in for P is. A contradiction is necessarily false. And the idea is this: if your opponent's position P ends up leading to its own contradiction, it is absurd, and therefore it ought to be logically rejected by rational people. Now, you might ask, well, why would you want to go and use something like an indirect proof? If your own position is too darn difficult or impossible to prove, another pathway for supporting your position is to take the opponent's opposite position of yours and to show that it is logically flawed. Now, you notice that it doesn't directly prove your own position. It disproves your opponent's position, thereby lending credence to your own. Now, the beauty of the author going from reductio ad absurdum straight into his discussion of 3 kinds of propositional statements is because I just showed you one of the 3 kinds of propositional statements. We have tautology, contradiction, and finally, contingency. Now, admittedly, this terminology isn't something that we will be concerning ourselves with when we're doing categorical syllogisms. This kind of terminology would apply more directly if we were doing propositional logic. Folks, a tautology is a statement that is necessarily true. Now let me show you what the skeletal structure of any tautology will look like. P or not P. Now the reason why that statement is necessarily true is, remember what the or means. Only one side of the or has to be true in order for the entire statement to be true. And every time that P is true, not P will be false, but the statement is still, total statement is still true. And if P is false, not P will be true. So the or statement will still be true. So no matter what you plug in, it's still true. It's a book or it isn't a book. Well, guess what? That statement is trivially true whether or not the thing that you're referring to is a book or it isn't. It's a dog or it isn't a dog. Yeah, that's true. It is or it isn't. Contradictions are propositional statements that are necessarily false. I just went over that. It's a dog and it isn't a dog. Well, guess what? Whether the thing we're talking about is a dog or it isn't a dog, that statement will be necessarily false. Because in cases where it is a dog, not a dog will be false. So the entire and will be false. It's a book and it isn't a book. Well, how the heck can it be both the thing and not the thing? This is why this statement is necessarily false.
So with the contradiction, basically, if just hearing it, you'll be able to point out, right? Is it more or less?
Well, you should be able to see it when I've made it this obvious.
Yeah. So like, with the contradiction, it's not, well, let me start at the T1. The T1 is more or less, it's not asking about the question, it's forming the question, right?
Well,
it's not asking you to answer the question.
No.
Because it's a dog.
Well, technically, neither of them are questions. They're both statements.
Well,
this was it is a dog or it isn't a dog.
That's what I'm saying. So, like,
it is a dog and it's not a dog.
So the or and is with the side.
Well, remember what the or means. In order for an or statement to be true, all you need is one side of it to be true, and it's still true. For the and, both sides of the and have to be true. And because of the way this is written, no matter how you slice it, it will always be false. Yeah.
So when you say necessarily true or necessarily false, what do you mean by this?
Necessarily, it means regardless of what the truth of the content is, because of the way this is set up, this will always be true, regardless of what the truth of the things are that we're talking about. This will always be false. Yes, sir?
So it's kind of like validity assignment based off of
Well, yeah, because it's about structure. Now, this next one is about structure and the content. It is what is called contingency. You determine whether or not a contingent statement is in fact true, depending not just upon the structure, but also the truth value of its parts. Now let me give you an example of a contingent statement. If either I get a new loan or I get a new job, then we'll have money for a new house. If I can either secure a loan or I can get a new job, then we'll have money for the house. Now you'll notice that whether or not this total statement is true or not depends upon the truth value of the individual pieces. In other words, it matters whether these things are true or not. Because in order for H to be drawn from this, one or the other of these has got to be true. Now keep in mind, if both of these are true, that's fine also. This is a contingent statement.
How do you find?
L or R, therefore H. Go ahead.
Can you actually see if it's true?
Well, you would have to know what the truth values of the pieces are.
Okay.
Now, I'll give you another easy. This one will be even easier. He'll buy the house and he'll buy the car. Now, this statement is a true statement if and only if what? If he buys the house and he buys the car. He'll buy the house or he'll buy the new car. This is a true statement in the case that one of these is true or both of them are true. Now, the reason I mention this now, even though I probably won't hold you to it, is because most logicians use the connector or in what we call the inclusive sense, as opposed to the exclusive sense. Now, what I mean by the exclusive sense is the way that we tend to use the word or in everyday language. If I say, I'm going to the store or I'm going to the pub, we typically think that implies I won't do both. I'm going to be doing what? One or the other, but not both. Or in the inclusive sense means it's a true statement if I do one or the other, but if I do both of them, it still counts as a true or statement. Why? Because one side of the R is true. If one or more sides of the or are true, this would be a true statement. How about this one? He'll buy groceries and he'll go to work or he'll go to the pub. Oh. Now this statement is a true statement as long as what? This has got to be true, and one or the other or both of these have got to be true. Because that's the major connector, as logicians call it. Now, I hope that gave you an idea of what those three kind of statements are. Now, I'm just about out of time here, but I want to talk about these last couple of things. Folks, the author of the text does talk about something called inductive validity. I prefer not to talk about inductive validity. I prefer to refer to inductive arguments as arguments from strong induction or arguments from weak induction. Here's why. When we use the word validity in the technical deductive sense, remember the truth of the premises necessitates that the conclusion is also true. If we have what the author calls a valid inductive argument, we still can't have certainty. Instead, what we mean is something like this. The weight of the evidence, if true, is relevant and strong enough that we ought to draw this conclusion. In other words, I'll give you something. If you know that a human being is generally punctual, and you have seen it happen time and time again, and if said punctual person doesn't show up to class after 15 minutes, you'd likely think, well, I think he's not showing up today. Now, it doesn't mean he's not going to show up. But someone's track record counts as evidence. Or I'll give you another one. I have a student in another class who regularly attends, turns everything in, and disappeared for a week. I didn't infer that this person was a poor student. I inferred, because of this person's track record, that stuff had to have gone down very badly outside of school. Now, it turns out that my reasoning might be wrong. In this case, I was indeed correct. Because induction suggests we should predict the likelihood of future outcomes based upon the things that we have encountered already. Now note, if the things you've encountered are a very small set, you might not be able to draw a very strong probable conclusion. Because the strength of your conclusion is based upon how much evidence and how relevant the evidence is to the case at hand. Now, I actually end up giving some examples there. We'll be moving on to discuss informal fallacies next.